Hello, this is Vikram. Today I am here to give a lecture on recurrent neural networks. As coming to the topic, as a neural network is one of the most popular machine learning algorithms, as all we know, and also outperforms other algorithms in both accuracy and speed as well. As we use different neural networks to get the output. As a recurrent neural network, coming to the topic, today our lecture is about the RNNs, which is known as recurrent neural network. It is a type of neural network where the output from the previous step are fed as input from the recurrent current step. As coming to the traditional neural networks, all the inputs and outputs are independent for each other. But in cases like when it's required to predict the next output, thus RNN came into the existence. They can be helpful to solve the issues with the help of a hidden layers. As we can see, here is the input layer as well, where these are the hidden layers. Uh, and the main and most important feature of recurrent neural networks is hidden state. Here is the output layer, and we can see the graph of the recurrent neural network. As the fundamental feature of recurrent neural network is that it consists of at least one feedback connection. As we can see, uh, recurrent neural networks are very powerful as they combine two properties. Recurrent neural networks architectures can have many different forms. As we can know, one common type consists of standard multi-layer and different hidden layers where these can exploit the powerful nonlinear mapping capabilities. As coming to the types of recurrent neural networks, as we know, there are different types of recurrent neural networks, and one of those is one-to-one neural network. In this neural network, this type of neural network is known as a vanilla neural network. Basically, this neural network is used for general machine learning problems, which have a single input and as a single output. As we can see here, here it has a single input and a single output. And coming to the second type, one to many relation neural networks. This type of neural network has single input and multiple outputs. As we can see, this has a single input and it has a different multiple outputs. And the third type is a many to one neural network. As this RNN takes a sequence of inputs and generates a single output. As we can see, it has a sequence of inputs and generates a single output. Semantic analysis is a good example for this kind of neural network where a given sentence can be classified as expressive positive or negative statements. As a final type is many to many neural network. This relational neural network take a sequence of inputs and generates a sequence of outputs. Here it takes a sequence of inputs and this RNN gives and generates a sequence of outputs as well. For one of the best example of this many to many relational neural networks is um, machine translation. As coming uh, as the recurrent neural network, also known as RNN, is a class of neural networks which can be that allows the previous outputs to be used as inputs while having hidden states. As we all know, every neural network have the pros and cons as well. When coming to the as RNA has also the similar as same, it has advantages as well as the disadvantages as well. Um, when coming to this recurrent neural network, um, there are several advantages which can be summed up, and the few advantages are a possibility of processing input of any length, and it can easily process the input if it is very lengthy too. And the main and most advantage is model size not increasing with size of input. If we give the input size, the model size is not increasing. As well as the other advantages was computation takes into account historical information, and ways are shared across time. As these have the are advantages as well. And now coming to the disadvantages and the drawbacks, there are a few drawbacks as well for recurrent neural networks. uh, Competition is being slow, as we can by using this neural network, the competition was very slow. There is a difficulty in accessing information from a long time ago, and this neural network cannot consider any future input for the current state. And this is the major drawback of this recurrent neural network. And we can see how does this recurrent neural network work, as the information cycle through a loop to the different hidden layers. And there are different variations of RNNs that are being practically applied in our machine learning realistic problems. Here are the few different variations and architectures of recurrent neural network. Few of them are bidirectional neural network, gated recurrent units, and long short-term memory. As we bidirectional neural networks input from different steps, and coming to the long short-term memory, which can be abbreviated as LSTM. The idea of gating networks can be applied to make a state machine that is even more like computer memory, resulting in a type of memory is known as LSTM, and which is stands for long short term memory. But we won't go much details into here, as we can see. But the basic idea is that there is a memory at this at another awesome name for a general neural network. The input gate selects. Here we can see the basic graph of a recurrent neural network. These networks used to used to compute the output value. These networks have been used in applications like language translation with really amazing results. And here we can see the architecture given below. They designed a memory cell using linear logic sticks units with multiple interactions. Information gets into the cell whenever its right gate is on. The information stays in the cell as long as it keeps going into and turning into the read gate. As we can all know, the recurrent LSTM can be able to accurately predict the current state. As an example, let's say we want to predict the italic, italic word in the following. Alias is allergic to nuts. She can't eat peanut butter. It is a italicized sentence. The context of a nut allergy can be help us to elaborate. And for example, if a gender pronoun such as she was wanted to repeat the prayer, you may exclude that statement from the cell state. And there are several challenges where RNN has and how to solve them. The most common issues with RNN are gradient vanishing and exploiting problems. The gradients refers to the errors made as the reference neural network trains. If the if the gradient start to explode, the neural network will be able to explode and enable to learn. And there are two standard issues of standard recurrent neural network. One is here we can see one of them is vanishing gradient problem. This RNN enables you to model time independent and sequential data problems such as stock market prediction, machine transition, and text generation. Uh, Here we can see while training RNN, your slope can either too small or very large, and this makes the training very difficult. When the slope is too small, it is called as the vanishing gradient, and it can be used in the stock market prediction, machine translation, and text generation. By this, RNN suffer from the problem of this vanished gradient problem, whereas the gradients carrying information used in RNN, and when the gradient become too small, the parameter updates become insignificant, and this makes the learning of long data sequences very difficult, as it causes the issue of standard recurrent neural networks. And the other was exploiting gradient neural network gradient problem. When the slope tends to grow exponentially instead of decaying, it is called as exploring gradient. When training a model, if the slope tends to grow instead of decaying, it causes exploding gradient. The problem arises. This problem arises when the gradient and when large error gradients accumulate, resulting in very large updates to the neural network model waste during the training processes. Uh, Long training time, poor performance, and the bad accuracy are the major factors which are affecting and which are causing issues in gradient problems. Thank you.